So this is our first video about elimination. It's kind of our last strategy that we're going to do this year about solving systems by an algebraic method. I'm going to talk about these steps. They're up here at the top. I'm going to talk about these steps right up here in a minute, but I want you to look at this first example, and I want to just tell you why in the world we're not using something we already know. So on this first one, if you look at it really quick, there's not a y equals or an x equals. It's not easy to do by substitution. And even if I change it a little bit, so I'm going to look at this one, I'm going to solve it for y. I'm going to do it all at once. I'd get y equals 47. I'd have to subtract that 4x to the other side, and then I'd have to divide by 5, so I'd have to divide everything by 5. Look at those nasty fractions. I don't want to have to go over here and substitute in with those nasty fractions. That's gross. I'm not doing it. It's icky. There has to be a better way. And there is. It's called elimination. And it makes this super easy, no fractions, and very few steps. So that's what you're going to show us on your next assignment. You need to use this elimination method. But what it says is move the first step up here, move the terms so the like terms are all lined up. Now this first one's already done it for you. What I mean by that, look at this column right here. The 4x and the negative 4x, they're lined up from both equations. In this column right here, the 5y and the 2y, those are like terms, they're lined up. The 47 and the 2, the plain old constant terms, the numbers, they're all lined up. Now, this part is the most important. The equal signs are also lined up. So, what this second step says is multiply one or both of the equations to eliminate one set of like terms. Now, you don't actually have to do this multiply part, but I want you to look at what happens if we add, the next step is add the two equations together. What is 4x plus negative 4x? What happens when you, 4x minus 4x basically, when you add opposites? They cancel. We're going to end up adding two equations together to do the elimination method. Now that's possible because we know equations are the same on both sides. This side is equal to that side. I am allowed to add to this first equation two equal things. If I add 2 to both sides of an equation, that's allowed. I am basically doing that. I'm adding 2 to this side, but this is the same thing as 2. It's equal to 2, so I'm adding that to both sides. So, all right, that part is a little harder to understand, but we're going to add the two equations together. That's the whole idea of this elimination. And you're totally allowed to do it because you're adding two equal things to both sides. Now, so what we're going to do is we're going to add the two equations together. I like to keep my equal signs lined up, I like to put that equal sign there. So let's do that. Let's add these up. That's 49, not 47, sorry. 49. When you add 47 plus 2, add the like terms. Now here, I get 7y when I add 5y plus 2y. But here, 4x minus 4x is 0x. Now, I don't usually write that because what, I'm going to have plus there. What is 0 times x? Well, it's just 0. So let me erase that. And then what is 0 plus 7y? Well, 0 plus anything is just itself, so I really don't need to write it. What happens is that 4x minus 4x cancels out or eliminates. That's why it's called elimination. You eliminated the x from both equations, and now you can just solve it for y because all you have to do, divide by 7. Super easy to solve now that we got rid of that x. Now we know one of the answers. So now we solve for the remaining variable. That was y. We eliminated, canceled out one variable from step 2 after we added, and then we solved for that thing, that the variable that was left, y was left in our equation, so we solved for it. Now, substitute back into either equation, doesn't matter, just pick one. I'm going to pick this one, and I get 4 times x, oops, I don't know why I put parentheses, plus 5 times 7, because I'm going to put in my y equals, well, I know y equals 7 now, so I'm going to put it in. And I get equals 47. Now that I have that equation written out, I have 4x plus 35 equals 47. My equal sign needs to be fixed there. And now solve it just like any other algebra equation. We only have one variable. We don't have a y in there. We only have an x. It's easy to solve that. Let's see, 47 minus 35. Now, I see that I made a mistake. That's actually, oops, undo. That's actually 12. 47, I'll get my 35 back, minus 35. You get 12, not 8, crazy lady. And so now when you divide both sides by 4, you get 3. So now you get 3, comma 7, as your answer when you put it all together. So remember, your answer should be written as a coordinate pair because you get an X and a Y, that combination. Now, on this next one, notice that these aren't lined up. When I look here in this column, that's got an X and a Y, and that one also has a Y and an X. These ones are good, but I have to rearrange some things. So that first step is to move things so your equations are in the same order. So I'm going to leave this one alone because it's already in standard form. X first, Y second, equal a number. Now in this one though, I want my Y to be over here. It's a positive, so I'm going to put a positive, and my X is over here. I would usually just say, hey, it's 2X plus 3Y equals -6. You just have to reorder it. Just make sure you keep the signs together. Now, step 1 is done. All of the like terms are lined up and the equal signs are lined up. That's really, really important. The equal signs have to be together. So now, we don't need to do that, but we need to make sure that we can eliminate when we add. Okay, if I add my like terms together, I see -3y, plus 3y will eliminate. They make 0 when I add them. -3y plus 3y is 0. They eliminate. But now we're going to add all of our like terms. We're going to add the two equations together. We have 4x on that side. 2x plus 2x makes 4x. And then when we add these like terms, I get 4. So I quickly see that x equals 1. Now, we added and we solved. We did step 3. Now, we're going to substitute into either equation we feel like. I'm going to use this bottom one because it's here. There's no good reason. You can use the rearranged version like you have over here. That's okay. Or you can use the top equation. It really doesn't matter. Put it into 1. I've got my x is equal to 1. That's what I found here. So I'm going to put it in to the equation, and that's equal to -6. My equal sign didn't show up. All right, so I get 3y plus 2 when I multiply, right? 2 times 1 is 2. Equals -6. So now subtract. Now it's just algebra. I get -8 on that side, and I get 3y. So hey, it's a fraction, but y equals -8/3. You may also say -2 2/3. What you may not say is -2.67. That is a rounded, not exact answer. So you need to put exact answers into GMM. They will be in your priorities. And the last thing you need to do is put your answer all together as a coordinate pair, because this is really a point that they have in common, a point on a graph where they intersect. That's the common point. So at this point, I want you to stop the video and go to your homework and try 1 or 2 of those first level problems. They're labeled as they're labeled, I think, as easy, just add. And try those and then come back and try the second video when you're ready to move on. You don't need to do all of them, maybe 1 or 2, and then come back.